Okay, calculus students, so you're in for a real treat now because we are just starting the process of learning all of these different formulas and stuff for finding the derivatives. And you may remember the last thing that we learned when we were looking to find the derivative of a sum or a difference of functions. Well, we could simply find the sum or difference of their derivatives. Well, the rules for the derivative for a product and a quotient are not as simple as that. So let's take a look then at the formula for finding the product rule. So here we have it. So if we have two functions and we've got the product of them, well, we already know that we can do this by multiplying them out. But we're going to use this formula here, which says you can take, notice here are two functions. We have f of x times g of x, and it says you get the derivative by multiplying the first function, so you don't change it at all, times the derivative of the second, plus the second function times the derivative of the first. And yes, those could be in different orders. So let's take a look at this one. Just by virtue of the way it is when it's written out here, we're going to let this first function then be the f of x, and the second one the g of x, even though it doesn't really matter. And we want to find the derivative. So we're going to follow the rules. It says, first of all, you take the first function times the derivative of the second function. So let's do that first. Our first function was simply 3x minus 2x squared. And then the derivative of g of x, the 5 plus 4x, is simply 4. And then plus, we do g of x times the derivative of function f. So g of x is 5 plus 4x, and the derivative of f is going to be 3 minus 4x. Okay, so I'm just applying that simple power rule to each one of the functions. Now what we're going to do is simplify it. So we're going to distribute by the 4. And the next one we're going to double distribute. So we have 15. The outside, when we multiply, we get negative 20x. Inside we get 12. So minus 8x minus 16x squared. So when we combine, we get negative 24x squared plus 4x plus 15. Now, what I would like you to do right now is pause this and find the derivative another way, a way that you already know how to do it. And that would be to take our original function and multiply it out first, get it to look like a simple polynomial, and then find the derivative that way and compare it with our answer. So you're going to pause it now. I'm going to continue on. Alright, so here I have another function which is written as a product of two functions. Okay, well, to do this derivative, notice I have a 1 over x, so the first thing we would do is rewrite it as this so that I can do the derivative. And now we'll apply the product rule. Okay, so the first one stays the same. The derivative of x minus 1 is 1. And then we add. Now we want the second function times the derivative of the first one. Okay, so we want to simplify that. So we're going to write it as 1 over x plus 1. And this we're going to rewrite as negative 1 over x squared. Okay, so I'm going to get a common denominator here. So I get 1 plus x over x. You know, pause this if you need to and work that out. Plus a negative. And then the x minus 1 is going to go in the numerator. And x squared is going to go in the denominator. If you want, you can just change that plus sign to a minus to get rid of that negative sign up there. Okay, I'm going to get a common denominator. So I'm going to multiply this fraction times x. So I get x plus x squared minus x plus 1 all over x squared, which simplifies to x squared plus 1 over x squared. Okay, and we'll just leave the answer like that then. Here again, another way to do this is to multiply it out first and then do the derivative. Now let's take a look here and make sure we understand. So comparing differentiation rules. In the first one, because I have an x in here, this is a function, this would be our f of x. The second one is our g of x. I would use the product rule. So to get the derivative, we would take the first function times the derivative of the second plus the second function times the derivative of the first. So then we'd get 4x squared plus 6x plus 2x squared plus 6x. Combine like terms. So 6x squared plus 12x. On the second function, oh, I wrote exactly the same thing. Well, this is what I wanted for the second function. I didn't want this x in there. So in that case, because it's just a 2, we would use our constant multiple rule, where it says instead of doing the product rule, we would just say, well, to do the derivative of this, because 2 is a constant, we just take 2 times the derivative of this. So the derivative of that would be 2x plus 3. So because one of our factors was just a constant, then we can simply do the derivative this way. So the derivative would be 4x plus 6. So that's the difference there. So if I, once again, if I didn't have that x there. Okay? Okay. Now let's move on to the quotient rule. Take a look at this. In finding the derivative of the quotient, or when we're dividing two functions, notice f of x is in the numerator, the function in the numerator, and g of x in this instance is the function in the denominator. All right, so it says you would take the denominator, so there's the g of x that comes from the denominator, times the derivative of the numerator, and then subtract now. It's subtract, not addition, like in the product rule. The function in the numerator times the derivative of the denominator all over the denominator squared. And not the derivative of the denominator, just the denominator squared. Okay? All right, so it's right up there. So let's apply it to this one. So this is a quotient. I'm dividing two here. So this derivative then will equal the denominator times the derivative of the numerator, oh, I like that derivative, minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so when we simplify, we get 2x plus 3. Remember, on top now I'm distributing a negative and the 2. So negative 2 times x and negative 2 times negative 1. So it looks like those are going to cancel out. So I'm going to have a 5 over the denominator squared. So there is our derivative. So that is the quotient rule. Okay, and I know it looks kind of icky and you think, oh, I'm never ever going to be able to remember it, but it doesn't take very many repetitions to get that one down. Okay, so let's try it here now. This asks, though, for the equation of a tangent line to the graph of this. And notice we have a quotient here. I didn't write it in fraction form. You just have that division sign there. So first thing we have to do is get the derivative so we can figure out what the equation would be. Okay, so following along with our quotient, it says we take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, well, I'm not going to write that denominator right now. Let's just simplify the numerator. So we have to double distribute. So 8x minus 12x squared minus 8 plus 12x. And now I've got to take, or subtracting, a negative 3 times this. So it's actually like multiplying by a positive 3. So plus 6x squared minus 12x plus 9. So double check, make sure I have all the signs right. Combining yet a little bit more. Negative 12x squared plus 6x, so negative 6x squared minus 12x and 12x. So I have another 8x and minus 8 plus 9. So plus 1, so that's our numerator. That is all over the denominator squared. Okay, so that is our derivative. Okay, so now I have our formula for the slope. So, well, actually, in order to finish up this equation, I've got to give you a little bit more information. So we want to find the equation of the tangent line when x is equal to 1. Okay, so when x is 1, we need the actual point on the curve when x is 1. So if we substitute in to the original function, plugging in a 1 there, so we get 2 minus 4 plus 3. So we get 5 minus 4. So we get a 1 on, let me see, 1 over. And then in the denominator, we substitute in a 1. Looks like we get a negative 1. So when x is 1, y is negative 1. So that's our point on the curve. Then we need the slope at the point where x is 1. So we substitute that in to our slope formula. So now we want to put the 1 in there. So we get a negative 6 plus 8 plus 1. So that's going to be 9 minus 6, or 3. And in the denominator, when we plug in a 1, we get 2 minus 3, so negative 1 squared. So we get a slope of 3. Now we can write the equation of our tangent line with that information. So y is equal to 3x plus b. Substitute in a negative 1 here when we put in a 1 for x. So we get a b of a negative 4. So y is equal to 3x minus 4. So that's the equation of the tangent to this curve at the point 1. Okay? And we did that before, so hopefully you remember doing that. Our function just looked a little bit uglier than we've done before. Now we kind of have to be careful because not every quotient, when you look at the original problem and you think, oh, it's a quotient, I have to use the quotient rule. Well, not necessarily. So if we do a rewrite, like on this first one, so the equation is y is equal to, it's just a 6 in the denominator, so it's not a 6x. So I can just bring that out and think of it as a constant. And then again, it's not going to take the product rule to do that. We can simply, to get the derivative, take the constant times the derivative of the function. And simplifying then, we'd get 1/3 x plus 1/2. Okay? We didn't have to do a quotient or a product rule there. We could just use those rules that we started off with. Well, same thing is true on this one. So I see a quotient there, but remember how we did this before? We rewrote it and thought of it as 5/8, a constant, times x to the 4th. Okay? Then we could do our simple power rule. So the derivative is 4, maybe I'll write it down, 4 times 5/8 x to 1 less power. All right, so this will reduce. So we end up with 5/2 x to the 3rd. Okay, this next one, I have a 7x in the denominator. So remember how if we do a rewrite, I'm going to take the 7x. Now I have a product here. It's times this. So I'm going to take the 7x into this part of it. Okay, so we're going to have a negative 3 left outside. And then I've got 3x over 7x, which will give us 3/7, because the x has reduced out, minus 2x squared over 7x. And when I reduce that, the x from the denominator completely cancels, so I have 2/7 x. All right, now I can distribute through. Negative 9/7 plus 6/7 x. And then it's written as a simple polynomial, so my derivative is 6/7. Now take a look at this last one here. This one, if I rewrite it, I've got y is equal to 9/5 x to the negative 2. So here again, we don't have to use the quotient rule because I don't have a function other than just a constant term in the numerator. So I can bring that x squared up and write it as x to the negative 2. So then for the derivative, we do negative 2 times 9/5 x to 1 less power. So it looks like, when we simplify, we're going to have negative 18 over 5x to the third as the derivative. Okay, I'm going to give you one last example here. Now in this particular case, we are going to have to use the quotient rule, but I'm going to rewrite it a little bit. So instead, one way to do this is just think of the numerator as 3 minus x to the negative 1. Well, I'm going to simplify it even a little bit more by multiplying by x over x. So in this case, when we multiply by x over x, remember that's a giant 1. So I can multiply a fraction times 1 and not change the value of it. So the rewrite then is going to be 3x minus 1 over x squared plus 5x. So that looks a little bit better there. Now we are ready to do the derivative. And yes, I will have to use the quotient rule. So we take the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. And that will all be over the denominator squared. All right. And if you need to show that so you don't forget it, then go ahead and write that down. I'm going to choose to simplify first, the numerator anyway. So 3x squared plus 15x. So 3x times 2x is 6x squared, but I need to subtract it. I get a 15x minus 2x. So that's a positive 13x, but I need to subtract it. And then I get a negative 1 times 5. That's a negative 5, but I'm subtracting it. So one more step then. So negative for the numerator. Negative 3x squared plus 2x plus 5. And now we're going to remember then that we need the denominator squared. All right, so now you have some good examples to go back and look at. So this time what I'm going to ask you guys to do is try these problems. So I want to see if you can do some of these by applying the rules where appropriate, and then come back to class and see if you have any questions, because it's pretty easy to watch me do it, and then as you start doing your own, then you get some questions. So I'm going to have you try this time, so good luck with those, and we will see you in class.